Hello students, welcome to Umadevi Children Academy students. Today we are discussing the topic is ionic radii and ionization enthalpy. So what happened? What is the change occurs? The according to the group, according to the period in ionic radii, and what is the change occurs in the ionization enthalpy in a period or groups. So first one is the ionic radius. So what is mean by ionic radius? The removal of electrons from the atom result in the formation of cations, or whereas gain electrons lead to form anions. Okay, students, if the atom in which if we are remove the outermost electrons, this atom, if you remove outermost electrons, it forms cation, positive charge. The atom which is accept the electrons, then it forms the anions, extra electrons, they are anions. So this is we call it the ions. This is we call it the ions, right students? So ionic radius can be estimated by the measuring the distance between cation and anions in a ionic crystals. The ionic radii can exhibit the same trend of atomic radii. So here my students, so distance from center of the nucleus to the outermost electrons of the ions. Ions mean it may be cation or it may be anions, right? So distance from center of the nucleus to the outermost electron, center of the nucleus to the outermost electrons of the cations or anions. So that is we call as the ionic radius. The any ions, either positive charge ion, cation, or the negative charge ion, anions. If the distance of central part of the nucleus to the cation outermost electrons, that is we call it the ionic radius, or distance from center of the nucleus to the anions outermost electrons, that is we call it the ionic radius. Right, students? So the size of the anions are larger than the parent atoms. Anions. The anion size is larger than the parent atom because the addition of one more electrons, as a result the increase the repulsion and the decrease the effective nuclear charge. So already we have discussed what is effective nuclear charge. So students, look at here, this is the one of the atom, chlorine atom. The chlorine atom which contain the 17 atomic number 17. It means it contain the 17 proton equal to 70 number of electrons. So chlorine atom accept electron because it outermost want to attain the stable noble gas configuration. So when one electrons are added to the chlorine, then it becomes 17 plus 1 becomes 18. It means it turns into chloride ion. In chloride ion, the 17 proton and 18 electrons. Look at it here. In atom is neutral, positive charge 17 proton, 17 electron. So both are neutral, but both are equal, proton equal to the electrons. But here 17 proton but 18 electrons, the imbalance. So electrons are increases here as compared to the proton. Electron increase as compared to the proton. So due to the increased electrons, when one electrons are added to the chlorine atom, then the electron between them repulsions are occurs. Electron between them repulsion occurs. When electrons in which repulsion occurs, then the anion size greater than the its neutral atoms. Right, students? I will show you the example, students. Look at here, students. This is the sodium. Sodium is a neutral atom. It contains 11 proton, 11 electron. So it is neutral. Charge is 0. When sodium atom outermost loss is this electron, outermost electron, when it lost one electrons, then what happens, students? Then the again it becomes the 11 proton and 10 electrons. 11 proton and 10 electrons are left on the sodium. the sodium ion. So that's why it turns into sodium, turns into the sodium ion. So in which, so here the number of proton equal to number of electron. Here protons are high, electrons are less. So the number of protons are 11 and electrons are only 10. So all the 10 electrons are more attracted toward the nucleus. All these electrons are the more attracted toward the nucleus. They are more attracted, so that's why its size is reduced here. Right, students? But in case of chlorine atom, chlorine, the atomic number 287, the 7 electron, in which we are at the 17 proton, 17 electron. So it is neutral. In which we are add the 1 electrons. Then what happens, students? Look at here, the electron 1, 2, 3, 4, 5, 6, 7, 7 electron. But here 1, 2, 3, 4, 5, 6, 7, 8, 8 electrons. Outermost 8 electrons, so 17 protons and 18 electrons. Okay, students. So that's why the 17 proton and the 18 electron, the electrons are high number as compared to the proton. So that's why the electronic repulsion, one electrons are added here. So that's why the the electronic repulsion occur between the side by side atoms, or the electronic repulsion occurs inner electrons repulsed to the outer electron. These inner electrons also repulsed to the this outer electrons, right? Understood, friends? Or we may say the K shell electron repulsed to the L shell. L shell electrons are repulsed to the M shell. K shell repulsed to L shell. L shell electron repulsed to M shell. So repulsion occurs here. That's why its size is larger as compared to the atom. Understood, friends? Okay. Example of ionic radius of the fluoride ion is 136 picometer, whereas the atomic radius of the fluorine is 64 picometer. When you compare the fluoride ion and fluorine, so fluorine is the electronegative atoms, right? It's outermost having the outermost is the 9 electrons, outermost 9 electrons. When it accepts 1 electrons, accept 1 electron, it turns into fluoride ions, outermost 10 electrons. When if fluorine is there, the fluorine atomic radius is the 64 picometer. But when electrons are added, it forms fluoride ions. Its radius is 136 picometer, because the inner electrons are repulsed to the outer electrons. Inner K shell electrons are repulsed to the outer L shell electrons. That's why its size goes on increases. Right, students? Size goes on increase. That's why its picometer, the fluoride ion size is greater than the fluorine atom. Similarly, the atomic radius of the sodium is 186 picometer and the ionic radius is 95 picometer. It is 186 picometer and this is 96 picometer. Why size decrease? Because one electrons are removed. After removal of one electrons, remaining surrounding electrons are more closer to the nucleus. So that's why its size is decreases 186 to 96 picometer, 95 picometer. Right, students? We will find the some atoms and ions which contain the same number of electrons, called as isoelectronic species. Okay, isoelectronic species means the ions which having the, or may say species, or may say species which having the same number of electrons, called as isoelectronic species. Iso means same, same what? Electron means same electrons. Species, element, either the atom or ions, or you may say positive charge ions or negative charge ions, that is species. Right, students? So look at here the example: oxide ion, fluoride ion, sodium ion, magnesium ion have a same number of electron is 10. So isoelectronic species, when we are come from in this form, the magnesium atomic number is 12. Its valency 2, that's why it lost 2 electrons. After losing 2 electron, it becomes 10. because it lost 2 electrons here. So 10 electrons are left here. Next, sodium turns into sodium ion. Atomic number 11. It lost 1 electrons minus E. Minus E means remove 1 electrons. It remove 1 electrons means it 10 electrons. Right, students? The fluorine atom in which we are add 1 electrons. So it turns into fluoride ions. Atomic number 9, we are adding 1 electron, it turns 10. And the oxygen, atomic number 8, in which we are adding the 2 electron, it turns into oxide ion. It means we are adding the 2 electron, it turns into 10. Right, students? So look at here, the number of electron is 10, 10, 10, 10. Different species, but their outermost electrons are same. That is we call it the isoelectronic species. Right, students? So number of protons are different here, but number of electrons are same. Due to the number of electrons same, it is called as the isoelectronic species. Right, students? Radii would be different because the different nuclear charge. Whatever these species are there, these species, the radius are different here. Radii must be different. Why different? Because the nuclear charge is different. Every species having the different number of protons. Due to the different number of protons, different nuclear attraction. That's why different nuclear charge and different their ionic size. Cation with greater positive charge. That's why it's small. The radius is small. Greater attraction of the electrons. Nucleus. Greater attraction of the nucleus. Right? But in case of ions, the negative anions have a greater nuclear charge. Greater nuclear charge, it will be large radius. Greater negative charge, the large radius. Why large radius? Because anions are accepting electrons. After accepting electron, the what are the neutral atom electrons are there? They are repulsing to the new electrons. So that's why the repulsion occurs. Due to the repulsion, the nuclear charges are decreased here. Proton to the outermost electron, nuclear charge decreases because protons are less, electrons are high. Due to that reason, its size goes on decreases. Sorry, its size goes on increases here. The size will expand here, expand the size. Nuclear charge decrease and size goes on expand. Right, students? For example, chlorine. Last time we have seen chlorine turns into chloride ion. The size goes on increases here. So next is the ionization enthalpy. So amount of energy required to donate electrons or amount of energy required to remove electron from its outermost orbit called as ionization enthalpy. So here the definition: the tendency of an element lose electron called as ionization enthalpy. So any species are there, any species in which you want to remove electrons. For removal of electrons, we need energy. Similarly, a person is there, and this person want to throw the stone from one place to another place. This is a stone. He want to throw stone from this place to another place. Then what he need energy. If he have energy, then only he lift the stone and remove from one place to another place. Similarly, the atoms are there. The atoms are want to remove electron from its outermost orbit. They want to need energy. Right, students? That is called ionization enthalpy. Right. So the enthalpy means energy. Ionization means formation of ions. The formation of ion purpose, they need energy. Right, students? It represented the energy required to remove electron from isolated gaseous atom in a ground state. In other words, the first ionization enthalpy of an element, enthalpy change reaction. So any atoms are there, the atom the isolated atoms he mentioned here is X. This is the atom. Neutral atom. Why it is neutral atom? Isolated atoms, isolated gaseous atoms, because it contains the number of proton equal to number of electrons. Right, students. So whenever you want to remove electron from its outermost orbit, it it must be need energy. We have to supply some external energy to this species. When we add some external energy to this species, then it remove electrons. Right, students. So look at here. The X turns into X plus by removal of 1 electrons. So ionization enthalpy is expressed, or its unit is the kilojoule per moles. Right? Ionization enthalpy is we have to use the unit is kilojoule per mole. So second ionization enthalpy is higher than the first ionization enthalpy. What is second ionization enthalpy? Look at your students. This is a proton. First shell, second shell, third shell. Right? So electrons are present in the first shell, second shell and third shell. I will mention E1, E2, E3. Okay, I will mention here the this is the 10 proton. 10 protons are present here. The students. And 10 electrons. 10 proton and 10 proton equal to 10 electrons. When I remove these electrons, we will remove this electron by using some sufficient energy, like the X kilojoule per mole I use here to remove this electron. So this is we called as the remove the first outermost electron, called as the first ionization enthalpy. Removal of first outermost electron, called as a first ionization enthalpy. Right? If removal of the second outermost electron, either second outermost electron nearby this or this one, maybe here or maybe here, the removal of the second outermost electron, that is we call as a second ionization enthalpy. Second ionization enthalpy. Right, students? So when we remove this electron, the protons are high, electrons are less. It means again electrons are move closer to the nucleus. When electrons are move closer to the nucleus, students, the nuclear charge increases here. Nuclear charge increase means the removal of the second electron purpose require again large amount of energy than the this first ionization enthalpy. Right, students? This is another method. The first, the second electron, third electron, fourth electron. When I remove the first electron, I need only the X kilojoule per mole of energy required. Then it turns into proton. Again, electrons are here. Right, 3 electrons here, K, L, M, N. But here only the K, L, M. 1 electron is removed with the help of X kilojoule per mole. So when here the nuclear attraction is this much, when electrons are removed, the outermost electron nuclear attractions are increases here. So that's why a removal of this electron purpose we need greater energy than this X kilojoule or first ionization enthalpy energy. Right, students? So in the same way, the third ionization enthalpy requires the again higher energy than the second one. Right, students? So this is the K, L, M, N. This electron more closer to the nucleus as compared to this one. When you remove first energy ionization enthalpy, it requires X kilojoule. Again, if you want to remove this electron, we need the 2x kilojoule. If you want to this electron, we need a 3x kilojoule energy we require here. Right, students? So first ionization enthalpy having the atomic number is 60. The atomic number up to 60 plotted in the figure 3.5. So graph is quite striking. The maximum, the noble gases, why the maximum energy required in the noble gas? Because the noble gases are completely stable and their outermost electrons are completely fulfilled. So that's why it require maximum ionization enthalpy. Other hand, minimum the alkali metal. Alkali metals are reactive metals, and they want to stabilize themselves by losing one electron. So that's why alkali metals are require very less ionization enthalpy, and noble gases require very high ionization enthalpy. Right, students? So look at here the atomic number from 1 to 60, there we are arranged here. So when we require the helium purpose we need to 25 kilojoule per mole of energy, and the atomic number 3. So here the hydrogen we require approximate the 14 kilojoule per mole of energy, and the helium require the 24 kilojoule per mole of energy. Lithium again 400 kilojoule per mole of energy. So look at here, as we are the atomic number increase here up to neon, the ionization enthalpy increase. Again the alkali metal have a less energy. So all the alkali metal, look at here, they having the less ionization enthalpy here, and all the noble gases they having the maximum ionization enthalpy. So alkali metals are the minimum ionization enthalpy, and these are the maximum ionization enthalpy. Right, students? In addition, to notice that the first ionization enthalpy generally increases as we across the period and decrease descending groups. So first ionization enthalpy is increases as we go across the period. When we move across the period means lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So this is the across the period. Right, students? So 3.6 and 3.6b figure, the element of the second period and the first group, the table are mentioned here. The ionization enthalpy, atomic radius against ionization enthalpy. Okay, here atomic number, ionization enthalpy. Right, students? So the atomic number increase 0 to 10, 0 to 10. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So this is the second period of the elements. These are second period of the element. So as we move across the period, the ionization enthalpy goes on increases here. Ionization enthalpy increases. Why? Because all the electrons, as the atomic number increases, electrons are shifted into the same period. Electrons shifted in the same period. So that's why the ionization enthalpy increases. Look at here, students. Lithium 1s2 2s1. Beryllium atomic number 4, sorry, 1s2 2s2, and boron atomic number 5, 1s2 2s2 2p1. Questions. So in this case the electrons are shifted in the same second energy level, atomic number 3. It means the 3 protons 3 electrons. Atomic number 4, 4 protons 4 electrons. So again electrons shifted in the same shell. Proton increases, electrons remains in the same shell, that is second energy level. And atomic number 5, 5 proton 5 electrons. So electron present in the same second energy level, but proton increase here. So protons are increased, but electrons on the remain same shell up to neon. So that's why, students, the ionization enthalpy increases because increase the nuclear charge. Right, students? But when you remove from according to the group, first group, the ionization enthalpy decrease because the electron shifted in the differential. Electron shifted in the differential. Lithium 1s2 2s1. Sodium 1s2 2s2 2p6 3s1. Look at it, students. Here electron present in the atomic number increase 3 to 11. 3 to 11. The electron shifted in the different energy level. Here a second energy level, here third energy level. The electron shifted in the different energy level here. So that's why their atomic radius increase. As the atomic radius increase, their ionization enthalpy also less. That's right, ionization enthalpy less here. To understand this trend, we had to consider the two factors: attraction of electron toward the nucleus and repulsion electron from each other. So effective nuclear charge, already we have discussed the attraction from the electron to the nucleus called as the effective nuclear charge. Effective nuclear charge experienced by the valence electrons atom will be less the actual charge actual charge on the nucleus, because the shielding and the screening effect of the valence electrons of the nucleus in the intervening the electrons. So when any element shells are like this, so inner electrons are repulsing to the outer electron. This is we call as the repulsion force or shielding effect. When the electrons are strongly attracted to the nucleus, that is called nuclear charge. Right. If the repulsion is greater, when repulsion is greater, if number of shells are high. If numbers of shells are high, it means electron shifted into the different shells. If electron shifted different shell, it means the inner electron more repulsed to the outer electron. Inner electron more repulsed to the outer electron. If repulsion high, then students, repulsion high, inner electron repulsed to outer electron called as screening or shielding effect. Right, students? So if repulsion is high, screening effect is high, then nuclear charge is less. Screening effect is greater than nuclear charge, then the removal of electron is so easier, so ionization enthalpy less required. Right, students? For example, the 2s electron the 2s electrons in lithium shield from the nucleus inner 1s electrons. Right, students? So 2s electrons are more repulsed from the nucleus. When you compare the lithium atomic number 3 protons, 1s2, this is 2s1, 1s2 2 electrons, 2s1 1 electron. So these inner shell electrons are more repulsive to the m shell. As a result, so these electrons are experience the less nuclear charge as compared to this k shell electrons, because it is away from the nucleus as compared to this one L shell electrons, which is the experience less nuclear interaction as compared to the k shell. So removal of electron is so easier. So as a result, valence electron experience the positive charge, so less than actual charge of positive. So lithium, which repulsed by the inner electron, so lithium only exhibit the +1 state, because only the 1s2 2s1, so only these two electrons are repulsing to the 2s1, so 2s1 electrons are easily removed, so it attain the plus 1 state. So and it cannot be remove all the electrons, it cannot attain the +3 stage. For example, the sodium 1s2 2s2 2p6 3s1. So s orbital here completely filled, s orbital completely filled, p orbital also completely filled. If s orbital, p orbital are completely filled, the completely filled orbital causes more repulsion to these unfilled orbitals. They cause more repulsion to unfilled orbitals. Right, students? This is so shielding effect is effective when the orbital's inner shell is completely filled. The situation occurs in alkali metal. Yes, of course, I have given the one example, alkali metal. Ns electrons precede the noble gas configurations. It's the single electron present in alkali, but the outermost electron completely filled in the noble gas, so noble gas cannot experience any kind of shielding, so it is cannot release or accept electrons. When we move from the lithium to fluorine across the second period, the successive electron added in the same principal quantum level. The shielding and the nuclear charge inner core of electron does not increases very compensate. Increase the attraction of the electron to the nucleus. So already we have discussed student this point. Though as we have moved from the lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, as you move in this form, The electron present in the same shell here 1s2 2s1 1s2 1s2 2s 1s2 2s2 right 1s2 2s2 and 2p1. So electron present in the same second energy level, so that's why the nuclear charge is high, attraction is less. When we compare this one, the lithium to fluorine, so lithium 1s2 2s1, but in fluorine 1s2 2s2 2p5. So electrons are remain in the same energy level, second energy level. Here also electrons in the same second energy level. So electrons shifted in the same energy level, but the protons are increases. So that's why the nuclear charge is here high. Nuclear charge is high as compared to the shielding effect. Thus, across the period, the nuclear charge overweigh. Overweigh means the greater than the shielding effect, and the outermost electron are held the more tightly to the nucleus. So ionization enthalpy increases across the period. So nuclear charge increased nuclear charge is greater than the shielding. Consequently, the outermost electrons held more and more tightly in the ionization enthalpy increase across the period. So when you move across the period from lithium to fluorine, the ionization enthalpy increases because the electron present in the same shell. If electron present same shell, nuclear charge increases. Then the electrons are more tightly held to the nucleus. So that's why ionization enthalpy also increases. Right, students? As we go down the group, for example, the lithium to ferrocenium. Right, students? As we go down the group, the increasing the outermost electron being increasing rather than from nucleus. So the increased shielding effect, then nuclear charge. The shielding effect is as you move down the group, lithium to francium. So here electron shifted in the differential 1s2 2s1, but here 7s1. So here electron shifted in the differential, so that's why xenon and this one, right? Differential, so that's why the atomic size increases because of the shielding effect. Atomic size increase, electron shift in the differential, and repulsion increases. So repulsion is greater than nuclear charge. So here one of the example, first ionization enthalpy of boron is slightly less than the beryllium, even the greater nuclear charge. The boron, so one of the case here, boron atomic number 5 is first ionization enthalpy is less than the first ionization enthalpy of beryllium. What has happened here? According to the s orbital in boron, atomic number 5 1s2 2s2 2p1. Beryllium atomic number 4 1s2 2s2. The first ionization enthalpy of the boron is slightly less than the beryllium, because students, the here proton is high because atomic number high means proton is high and electrons are also same shell, but electrons are present here the p1. It means the electrons orientation is different here. The electrons are orientation slightly different. Due to slightly difference, the boron ionization enthalpy is less than the beryllium. Right, students? So look at here, the s electron attracted to the, so quantum level s electron is attracted to the nucleus more than the p electrons. So already I told you the electrons orientation different in the p orbital. So electron orientation different and their attraction also less as compared to the s orbital. So s electron is most strongly attracted to the nucleus as compared to the p orbital. Right, students? Beryllium electron removed during the ionization enthalpy s electron, and the s electron is, and one more point here, students, one more point. the boron 1s2 2s2 2p1, but beryllium 1s2 2s2. Electrons are completely filled here. Electrons are completely filled, and here also electrons are completely filled. Already told you, the completely filled orbitals are more repulsing here. So completely filled orbitals are more repulsing, repulsed due to repulsion. Its ionization enthalpy is less. Right, students? So the ionization enthalpy of s electrons, whereas the electron removed during the ionization enthalpy of boron from p electrons. The penetration of 2s electrons from the nucleus is more than that of the 2p electron, and the 2p electrons of the boron is shielded from the nucleus inner 2s electron. So that's right. That's the 2s electrons of the beryllium. So boron 2 electron, outermost electron shifted in the p orbital. So that's why the boron 1s2 2s2 2p1. So this 2s2 electron and 1s2 electron both are combined to repel, because both are fulfilled here. So both are fulfilled, it means these both are repulsion to the p orbital. And s electrons, which is the spherically rotation, the spherical rotation of s electrons are more closer to the nucleus than p orbitals. Therefore, it is easy to remove 2p electrons from boron as compared to the beryllium. Right. So boron has a smaller ionization enthalpy as compared to the beryllium. These are one of the important points, right? And similarly, the ionization enthalpy of oxygen is compared to the smaller. The small ionization enthalpy of oxygen as compared to the fluorine. Right, students? The small and first ionization enthalpy of oxygen compared to the nitrogen. The nitrogen in which the electrons, the p orbitals are completely filled here. 1s2 2s2 2p3. 2p3 means each shell which having the equal energy here. Why equal energy? Because all are singly occupied. In oxygen 1s2 2s2 2p4. 2p4 means first we single occupied, after that this one. So again it imbalance, again it unstable, because here the 2 and here 1 1. So that's why it is unstable. So this pair again refers to this one. So ionization enthalpy of oxygen is less as compared to nitrogen. Right. So this arises because of the nitrogen atom. The 2p electron resides in the different atomic orbital. Hund's rule already we have discussed here. So 2p electron must be occupied in the 2p orbital, resulting increase the electron repulsion. So 2p orbital, the oxygen in which the repulsion occurs between the 2p pair electron, 2p unpaired electron. So that's why the oxygen have a less ionization enthalpy than nitrogen. So easy to remove the fourth 2p electrons from the oxygen as compared to the nitrogen. Right, students? So this is about today's topic, students. If you find any doubt, ask my students. Thank you so much.